Don't matter. All right, this video is on how to write a molecular formula. Remember, a molecular formula is not the reduced or simplified formula. It's the formula that's going to have the subscripts where you're like, hey, do I need to simplify this? No, that's the point of the molecular formula. It's the non-reduced, the non-simplified formula. Got it? So again, C12, H24, O12, 12, 24, 12, they can be reduced. I know, but we're not going to do that when we're doing a molecular formula because that's the point of the molecular formula. It's not reduced. So here's the things that we need in a molecular formula, okay? So I'm going to put right up here, these are the needs, all right? These are the things that they got to give you. If they don't give it to you, then you can't do it, okay? If they don't give this to you, you cannot do it. Number one, you need an empirical formula. If they don't give you an empirical formula, or for the sake of this video, I'll say it in regards to your homework tonight, if they don't give you an empirical formula, or they don't give you what you need to get an empirical formula, then you cannot solve for a molecular formula. Okay? So, chicken and the egg, which came first? Empirical. You can't do a molecular without an empirical. Okay? You can do an empirical without a molecular, but you cannot do a molecular without an empirical. All right? So that's number one. Number two, we need what we call, there's two different names for it. I'm going to go ahead and give you what the most common name is, the empirical molar mass. Okay? The empirical molar mass is basically the molar mass for the empirical formula. All right, so again, just like we've always done a molar mass, where you do your inventory and you multiply it by the mass for each individual element, and then you add them all up. Well, the empirical molar mass would be the molar mass specifically for the empirical formula. All right, and then the third thing you need is you need some call it the molecular molar mass. Some people call it the experimental. All right, I'm going to put a little asterisk right here. And I'm going to put a little asterisk. I won't put an asterisk there. The one with the asterisk, they have to give you. Because you cannot figure out a molecular molar mass if you don't have a molecular formula. Like, you can't do an inventory for something that you don't even know that you have. So the empirical molar mass, number three is going to be it has to be given to you in the problem. Number one and number two, they don't have to give it to you directly. They could give you the information you need to figure it out. Like here, they may not give you exactly the empirical formula, but they'll give you what you need so that you can figure out the empirical formula. Because once you have the empirical formula figured out, then you can figure out the empirical molar mass. Does that follow? I'm losing you. All right, it's okay. I already done lost you apparently. So, but number three, they have to give you. They can't lead you to it. They can't indirectly give it to you. That has to be given to you directly. Okay, like an STD. Okay, it's got to be given to you directly. You can't get it through any other means. All right. So here's what we're going to take a look at here. So let's take a look here at a molecular formula. All right. So we're going to say here, molecular formula. Like you said, this one's I told you this is the easier one. That's more direct. It's simple and direct. So the question is, what's the molecular formula? All right. Well, then obviously the thing that we'd have to know is this. We'd have to know what is the empirical formula. So the empirical is CH. That's the empirical. I'm giving it to you. Okay. Like in this example, I'm giving it to you. And the molecular molar mass is 78 grams for every mole. All right? So 1 mole equals this many grams, 78. All right? So that's what it is. Molecular molar mass is 78 grams for every 1 mole that I got of it. So we good right there? Okay? Given to you, don't question where it came from. Given to you, don't question where it came from. Okay? What is the one thing I'm missing? Number two, the empirical molar mass, right? You can figure that out though. So go ahead right now while I write on the board, figure out the empirical molar mass. Okay, it's the mass of the empirical formula. Okay, it's the mass of the empirical formula. Because my empirical formula is made up of 1 carbon and 1 oxygen, then I'm going to add 12.01 plus 1.008. And when I do, I get an empirical molar mass of 13.018 grams for every 1 mole. All right? So that's your empirical molar mass. Because I figured it out. I didn't give it to you. I had to figure it out. Are we good right there?
It's like
Ma'am?
it's more to it.
It's what? I didn't hear you. Question mark, what'd she say?
You said is there more to it?
Oh, there's more to it because we ain't done. We ain't got the molecular formula yet. I'm just saying this is the information.
How did you,
So I told you I'm listening.
Thank you.
how did you get
It doesn't hurt.
13.018?
Bobby, what'd you say?
So I'm trying to get next.
Bobby, what'd you say?
How did you get 13?
I added 12.01 plus 1.008.
That's what we did yesterday. I thought we were doing something with the percentages.
Huh?
I thought we were doing something with the percentages.
I mean, no. I'm just getting this right here. You know what I'm saying? Like, I haven't even gotten into solving for the molecular formula yet. This is just my setup. Remember I said you need these 3 things, right? Well, there's 1, there's 3, and I had to figure out 2. Now that I got my 3 things, now I can get to work. All right? So now when I get to work, all I got to do now is simply take this. I'm going to take the molecular molar mass divided by the empirical molar mass, all right? And that's going to get me my multiplying factor, all right? Some of y'all might consider the MF something else, but in my case, I'm considering it the multiplying factor. So when I do that, I'm going to get 78 divided by 13.018. Okay? And so when I do that, I get 78 divided by 13.018. I get the number 5.99. Okay?
What is it?
1/7. Multiplying factor.
How much we see?
Depends. Because 5.5 would be 6, but I wouldn't write 6 for 5.5.
So you're done.
Oh, but 5.99.
Correct. But don't assume you always just round to the next number. Because in 5.5, right, like this is literally the exact same thing we just went through in empirical formula, right? 5.99, is that super duper close to 6?
Yeah.
So I can put 6. But is 5.5 super duper close to 6? What would I need to do to it? I'd have to double it. Okay? Like if I had 5.33, what would I have to do? Triple it, right? So again, just kind of the same rounding thing that we talked about before. Sometimes you can round, sometimes you got to double or triple or quadruple. All right? So, yes, I can take this right here and simply say 6. Now that's not a formula. So, still not done. All right? That's my multiplying factor. But when I say multiplying factor, I go here to my empirical formula, right? My empirical formula was C and H, right? What's my subscript right now? 1. What's my subscript here? 1. Because there's no number. All right? Like that's my empirical. All I did was write my empirical formula down, guys. Like that's what we had to start with, correct? It's right behind me. I know some of you can't see because I'm in eclipse. But it's right there, C1H1. There's my multiplying factor. So now what I'm going to do is I'm going to take that number and multiply it by that factor. So when I do, I get C6. And then I'm going to take that subscript and multiply it by that factor, and I get H6. And that is my molecular formula.
You don't simplify them.
No, because that's the whole point of a molecular formula. If I want it simplified, it'd be called the empirical
So you
formula.
saying what number you get What the MF, whatever.
is what I will multiply all the subscripts by. All right, and then once you do that, you're done. Okay? Are we good? That concludes the recording of Molecular Formulas video.